Welcome to ChemVid Redox Reactions. So, electrochemistry is the study of electricity, using chemistry. So today we're going to talk about how electricity takes place, and that is through redox reactions. So if I were to define a redox reaction, it would be any chemical reaction that transfers electrons. So it allows the electrons to transfer from one side to another. Oxidation is when you lose electrons, and reduction is when you gain electrons. So as you see over here, oil rig is one of the best ways I know to remember which is which. So oxidation is loss, reduction is gain, and I remember it as oil rig. So that is oxidation and reduction. Now, to better understand what that's talking about, I'm going to look at my examples in number 1. So aluminum by itself has no charge. So we say it has an oxidation number of 0, since it has no charge. Iron has a charge of 2+. Oxygen has a charge of 2-. Iron by itself is neutral, so it has 0 charge. Aluminum has a 3+ charge, and oxygen has a 2- charge. So in this case, the only things that's transferring are the electrons. So I'm going to look, and I'm going to see, well, what happened to aluminum? Well, aluminum went from 0 to 3+. And in order to become more positive, I know that I have to lose electrons. So aluminum lost 3 electrons. And according to my rhyme, if I lose electrons, I'm undergoing what we call oxidation. Oxidation is loss of electrons. Whereas if I look at iron, If I look at iron, iron goes from 2+ to a 0 charge. So in order to get closer to 0, he would have had to gain negative or gain electrons. And if he gained electrons, that means that he was being reduced. Oxygen, however, stayed the same. It had nothing changed, so it's neither oxidation or reduction. So when we talk about oxidation as being lost, we're talking about when an atom loses electrons and becomes positive or more positive. And reduction is when an atom has a positive or is neutral and then becomes more negative or neutral in this case. Alright? So let's go try down here. Zinc in its normal state has 0 charge. It's just a normal atom. Oxygen is diatomic and therefore has no charge. It's just a molecule. But this zinc oxide is an ionic compound. And I know from the periodic table that oxygen has a -2 charge, and zinc has a +2 charge, because if oxygen has a -2, zinc has to be a +2 so that they equal 0. So I'm going to look, zinc became more positive, so I know he lost electrons, so he is being oxidized. And then oxygen went from neutral to a negative number, which means he had to have gained electrons, so he is being reduced. Alright, next one. Sodium is just a regular old metal, so he's going to be 0. H+ tells me the charge right there. He's +1. Sodium plus is 1+, and hydrogen is diatomic, so he's 0. So sodium went from a 0 to a +1 charge, which means he lost electrons, so he's being oxidized. Hydrogen went from a +1 charge to a neutral charge, so he must have gained electrons, so he's being reduced. That is the basics of redox reactions, being able to see what charges they were, find out if they were oxidized or reduced, and then using that to determine what kind of electricity it's going to produce. So if I go over here on my notes, some of the oxidation numbers that you will need to know are right here. These are the rules of oxidation numbers. So you might want to go through and look at them. Most of them are pretty familiar. You'll recognize their charges from the periodic table. Others, there are some exceptions. For instance, the oxidation number of oxygen is always a -2, like it is on the periodic table, unless it's in hydrogen peroxide, in which case it is a -1. Okay? So there are a couple exceptions, but mostly it stays pretty much the same. So given these rules, I would like you to try number 2. See if you can determine the oxidation numbers for these molecules. All right? And the oxidation numbers are these numbers that we wrote here on the bottom. They're charges. Okay? So go ahead. Okay. So potassium is right here on my list. Any alkali metal or alkaline earth metal has the same charge that it would normally have. So potassium is going to have a +1 charge. Oxygen is always -2 unless it is part of hydrogen peroxide. And then I need to look at my overall charges to find chlorine. So potassium is a +1. Then there are 3 oxygens, so that's 3 times 2 is -6. So the total charge of all of my oxygens together is -6. And I see that this atom, or this molecule, has no charge. It has a 0 charge, which means all of my charges have to equal to 0. So I need to find out what number, if I add in here, +1 plus something minus 6 will equal to 0. And I determine that number is +5. Because if I do +1 plus 5, that's +6. Minus 6 is equal to 0. So potassium's number, oxidation number, is +1. Chlorine's oxidation number in this case is +5. And oxygen is -2. Because we want the charge for an individual atom, not the total charge. All right? We need the total charge in order to find out the chlorine. But when it asks for the oxidation number of each atom, we're talking about just one atom. So let's go over here. Sodium, I know that sodium is part of that first group, so I know this guy is a +1 charge. Oxygen, again, is a -2. So 1 times 2 is +2 total charge. Oxygen would be a -6 again. Again, there is no charge, so I know it has to equal 0. So my sulfur must be a +4 charge, because +2 plus +4 minus 6 is equal to 0. So the charges are the oxidation numbers for my atoms. Sodium is +1, sulfur is +4, and oxygen is -2. All right, let's move on. Okay, so in these practice questions, it's just asking for the oxidation number for each individual atom. So I'll do A with you. Sodium is +1, but there are 2 of them, so that's +2. Oxygen is a -2, but there are 4 of them, so that's a -8. There is no charge, so this has to equal 0. So sulfur needs to be a +6 in order to equal 0. So +6 is the oxidation number for sulfur in sodium sulfate. Let's see, let's jump down to E. Nitrogen. So oxygen, again, is a -2 charge. There are 2 of them, so that must mean that that is -4. Nitrogen would therefore have to be a +4, since there's no charge and it has to equal 0. So nitrogen is a +4 charge. Now let's go over to G. So G is a little tricky. So, oh my goodness, there's 7 oxygen. And so that gives me a total charge of -14. Okay? And it's neutral, so I know it has to equal 0. Hydrogen is always +1. There we go, so +2. So that means the total charge for sulfur must be a -12. However, there are 2 sulfurs. So what is the charge, or the oxidation number, for just one sulfur? It's 12 divided by 2, which is a -6. Okay? So whenever you're doing this, be very careful of how do you deal with if they're multiplied by 2, multiplied by 3, multiplied by 4. Make sure you're talking about just one atom. All right. The next one I'd like to do is this guy right here, F. So oxygen again is -4 times 2 is a -8. Hydrogen is +1. And if I look, this guy has a charge. So he's going to have to equal a -1. So +1, and then if this guy is +6, that's going to give me a remaining charge of -1. So +1 plus 6 minus 8 is -1. So I know that my sulfur has to be a +6. Alright, so now I would like you to try the rest of these and check your answers. So go ahead and check your charges. And this is the basics of everything we're going to do for this topic. So now I'd like you to go down in your notes and let's look at question number 4. Which element is being oxidized and which is being reduced? Okay, so with these equations, number 4 is asking which element is oxidized and which is reduced. So in order to know that, I need to know where the electrons are going. So my first step is to write the oxidation numbers for each of my reactants and my products. So let's start off with A. Zinc is in its standard state, so he is 0. H plus has a 1 plus charge. Zinc is 2 plus. And hydrogen is in its standard state, so it is 0. So then I compare. Zinc is going from a 0 to a 2 plus. That means that zinc has lost electrons and become positive, so he's being oxidized. Oil rig. Oxidation is loss. Then I look at hydrogen, and hydrogen is going from 1 plus to 0. That means that it had to gain electrons, and reduction is gain. Alright, so I look at them, I find their oxidation numbers, I find out which is which, and then I can find out if they're losing electrons or gaining electrons. Okay, now let's skip down to H. So I'm going to do the same thing. Sulfur I know is a -2 because of his position on the periodic table, which means that lead has to be a +2. H2O2 is one of my exceptions, so oxygen is actually a -1, but there are 2 of them, so it's a -2. And then hydrogen is a +2. Lead over here, so sulfate is a -2 charge, which means that lead is a +2. Oxygen is -2 times 4, which is -8. It has to equal 0, so sulfur is +6. I look over here, we have a -2 and a +2. Alright, so if I look, lead stays +2, so nothing has changed. Sulfur, however, goes from a -2 to a +6, which means that sulfur had to lose electrons to become positive, and that is oxidation. Then hydrogen goes from a +2 to a +2. Oxygen, remember one oxygen went from a -1 to a -2. So he actually had to gain an electron. So in this case, oxygen is my undergoing reduction. Okay? So what I would like you to do before you come to class, I want you to finish A through H. So the first 2 pages of your notes need to be done. When we get to class, we'll go over balancing redox reactions and electrochemistry. Alright? Thank you for turning in, and we will see you in class.